This is Shalom Siddiqui. As we discussed about previous lecture, we discussed about the shear force diagram. So today we will going to discuss about numerical on bending moment diagram. So we have the same question as per our previous lecture. This is a cantilever beam and this is a overhang span. So in cantilever beam, these are loads are applied on particular points. So this is a point load, this is also point load. This is a UDL, uniformly distributed load. This is point load, and again this is a UDL. So now today we will discuss about how to draw bending moment diagram and how to calculate the bending moment diagrams values. So we will start bending moment values. So as you know that all of you that the starting from left to the right, you can say that from your left to your right. So start from F to A. So first point is our F point. So bending moment, how to calculate the bending moment diagram and how to calculate the values of bending moment. In bending moment, the formula for load into perpendicular distance. So suppose this is a load and this is a perpendicular distance. So from this formula we will have to calculate all these type of load on particular beam. So first is point F. The load is applied is 15 kilonewton, but the distance is 0 because at point F the distance is 0. So the load is 15 multiplied by 0 equals to 0 kilonewton meter. Now come at point E. Calculate the value of E for bending moment is 15 and the multiplied by distance, perpendicular distance. The load is this and the distance is this. So 15 multiplied by 22. 15 multiplied by 2. And you also take the negative value because the moment will apply is downward direction. In downward direction is minus y in the axis, so we will take minus value. So it is minus 15 into 2 and we will have to add minus 10, but the value at point A perpendicular distance is 0. So the value comes from E calculated is 15 multiplied by 2 is minus 30 kilonewton meter. Now come at point D. At point D, this is 15 multiplied by whole distance 2 plus 1. So 15 multiplied by 3 is minus the 45, and the distance we will have to add at point E because the load is applied like that and perpendicular distance is 1. So 10 multiplied by 1, it is minus 10 equals to now we will add from these two values. So our values comes in minus form. So minus 45 and minus 10 is 55 kilonewton meter. Now come at point C. Again I am saying that this is a UDL. Now the bending moment is different. How to calculate? I am going to discuss about that. So first let's begin from point F. The load is 15 and the multiplied by distance is 2 plus 1 plus 3 is 6. 15 multiplied by 6 is minus 90 because minus sign is we will going for downward direction. Now minus 90. Now at point E, 10 multiplied by 4 is minus 40. Now at point this load is 15, this load is 5, but this is a UDL. As per our previous lecture, we discussed about the shear force diagram. The load is applied from D to C, so we will multiply by distance. So the distance is, the load is 15. The load is 15, but we will add its CG. It's converted into point load. So its CG like in the midpoint. So the CG is 3 by 2. Now we will calculate from this value, and the value from 90 minus 40 minus 15, 3 by 2. I think it will come as calculated and the value is I guess 152.5 kilonewton meter, and you can calculate it by your calculator also. Now come at point B. At point B again we will going to start from first. So the load is 15. The 15 multiplied by this is 6 plus 8. 6 plus 2 is 8. 15 multiplied by 8, I guess 120. So minus 120. Now come at point 10 E. The load is 10 and the value is 6. 10 multiplied by 6 is minus 60. Now at point C, the load is 15 because this is a union. 15. The load is 15. Its CG is 3 by 2. Now we will add the distance of 2 because the CG is applied only in particular portion in UDL. So the CG is applied on between C and D. Now we will have to add distance 2 because we are in the point of, we are at the point of B. So 15 by 2, 15 3 by 2 plus 2, and the value we will add 2, and now the value is I guess is minus 232.5 kilonewton meter. You can calculate by your calculator because these are the values that I have calculated. So my values is like that, and the value for now the value we will calculate the bending moment at G point. In G point again we will going to start at first. So 15 multiplied by this is 8 and this is 9. So the value is minus 135. 15 5 59 15 multiplied by 9 is 135. Now minus 10 multiplied by 3 1 4 5 6 and 1 7 is 10 multiplied by 7 is 70, minus the UDL is 15, CG is 3 by 2 plus add the distance is 3, and I guess the value is, my value is minus 277.5 kilonewton meter, and you can calculate by yourself. Now the last point is A point. The A point again we will going to start from first. So the value for first at point F is going to start like that. Minus 15, the load is 15 and the distance is, this is 9 plus 5 is 14 multiplied by 15 is 210 minus the load is 10 3 4 5 6 7 plus 5 is 12 multiplied by 10 is 120 minus 15 is the UDL, the load which are applied on particular portion is the CG is 3 by 2 plus add all these distances 2 plus 1 3 plus 5 8, and now we are coming from point B. The value is, the load is 5 and the distance is 5 multiplied by 6 is 30. I'm going to write the direct value is 30. Now the point is, now we are come from UDL. The UDL is minus the UDL, as I discussed that the UDL you have to multiply by its distance. So 10 multiplied by 5 is 10 multiplied by 5 is 50, and the CG is 5 by 2. All these values cancel out is 25. And the value is come from by calculator is minus 627.5 kilonewton meter. So these all are values from bending moment diagram. Now I am going to draw the bending moment diagram. So come here, and this is the cantilever beam. All these values that we have is minus, so we will draw from the downward direction. Now I am going to say saying that the point load. Now when we draw bending moment diagram, so in point load you will go from like that in a slope way, and the value for bending moment diagram for UDL, in UDL you will going for parabolic form like that. So the value from F is 0. So this is a point F, E, D, C, B at point G, and this is a point. Now at point F, the value is 0, so start from here, and the load is point load, so we will go for like that, and again the point load is like that, so we will go like that. Now the value for is, this is the bending moment diagram for UDL. Now what I have discussed that this is the, you will apply as a parabolic. So from D to C is parabolic form. Now you can imagine that when the one load is applied on a particular beam, the overall load will transfer from particular point, from one point to other point. All these load are transferred for a particular, means you can say that this is a UDL. The UDL are applied from throughout the beam. So the all values will come in the form of UDL. This is point G and this is point A. So draw, this is our bending moment diagram for a cantilever beam. Bending moment diagram for a cantilever beam, and you can write your values. For this is a 0, and at point G, at point E is minus 30 kilonewton meter. At point D is minus 55 kilonewton meter. At point C is minus 152.5 kilonewton meter. Now at point B is minus 232.5 kilonewton meter. At point G is minus 277.5 kilonewton meter, and the last value for A is minus 627.5 kilonewton meter. So this is the bending moment diagram for cantilever beam, and as per previous lecture we discussed about the shear force diagram, and now today I discussed about the bending moment diagram. So we have completed from cantilever beam for bending moment diagram for shear force diagram, bending moment diagram for cantilever beam, and as we go for previous lecture before that, there's one type of different type of beam, different type of load, and different types of support, and one numerical problem on moment. All these we discussed. So we discussed all these values and this particular topic. Now next video we will discuss about the bending moment or shear force diagram for the simply supported beam. And if anyone has doubt in any queries and any points, so mention your comment in the below comment section, and I will discuss your comment. I will discuss your problem in the comment section. And if also if anyone did not see yet now the shear force diagram as a previous video, so please go and watch my video for shear force. And this is the bending moment diagram. You can imagine that when you have to discuss when you go through these two types of video, your concept is also cleared. Your concept will also clear from shear force diagram and also bending moment diagram. And again I am saying that if anyone has any query and any questions and regarding for these type of topic, so please mention your views and mention your comments in the comment section. And there is one description box, so I will mention some detail about the bending moment diagram in this video. You can go through that and watch this video. Thank you everyone.